morning. In this video, we are going to discuss the important measuring tool called Autocollimator, which has a wide range of applications like to measure the precision alignment, angular movement, small angles, flatness, straightness. For calibration also we can use this type of optical non-contact type instrument. So the optical non-contact type angular measuring tool, here what we are going to see is autocollimator. Generally optical instruments for angular measurements follow few basic principles like magnification, accuracy, alignment and interferometer. These principles will drive the development of large number of measuring instruments and the comparators, including autocollimator. It is an optical instrument to measure small angles with a high very sensitivity. It has a wide variety of applications including angular movement, straightness, flatness and calibration. The laser is used here as interferometry. That's why we are getting very accurate and precision values. Here we are using a special type of telescope to measure the small angles with a high degree of resolution. The principle involves it projects a beam of collimated light onto a reflector, which is deflected by a small angle about the vertical plane. The light reflected is magnified and focused onto an eyepiece or a photo detector. The deflection between the beam and the reflected beam is a measure of the angular tilt of the reflector. If you look at this diagram, you can easily understand. This is a normal with the workpiece. The plane reflector also we can call it as a workpiece or angle we are going to measure. If this is at 90 degree, the workpiece or plane reflector is kept at 90 degree. The light rays follow the same path and reaches the source. It follows the same path on which it reflected on the reflector and goes back following the same path and reaches the source mode. If the angle of the reflection is tilted, the light ray is reflected back and its original path is brought to focus at a point coincident with the origin point. If the angle is reflected by theta degree, this angle is theta degree. This angle is theta degree. We want to measure this angle. Very small angle also can be measured. For this we are using this instrument. The basic principle of this autocollimator is, if this angle is tilted, the light rays, it has to reflect back following the same path, but if the angle is reflected, it will not follow the same path and it will follow the another path, and the image will be falling on the focal plane at O dash. Instead of O, it will fall on the O dash. The distance between D, this O and O dash, that is a displacement, is given by 2 theta. This angle is a 2 theta into the focal distance, the distance between 2 points, that is the focal length of the lens. So we can measure this D and we can convert it into the angle, which is the required measurement what we need from autocollimator. So D is equal to 2 theta into F. Very simple formula, 2 theta into F. Theta is in radians. If you look at the construction, it has a light source, this observer eye, this incident beam, this objective lens, cross or reticle, and plane reflector. This reflector, if it is straight, it follows back the same path of light rays. If it is getting reflected, it will follow another path, and here we will note the difference. That is the basic concept of working of autocollimator. The same is explained here. To measure, we have the micrometer, the distance d, optical return path reflector square. This optical return path of reflector is a tilted. Reflector here is nothing but workpiece. This diagram gives more clarity. When reflector M is tilted, the focal length is the distance between the eyepiece and objective lens. It is in the reverse direction. See, look at this measurement. May be classified into three types: visual, digital, and laser collimator. The reticle is an illuminated target with a crosshair pattern which is positioned in the focal plane of an objective lens. A plane mirror perpendicular to the optical axis serves the purpose of reflecting an image of the pattern back onto the observation point. It can be easily measured by means of eyepiece, that is d equal to 2 into f theta. F is the distance between objective lens and reflector. Autocollimator, it is clear from this relationship, the sensitivity depends on the focal length of the objective lens. The longer the focal length, the larger the linear displacement for a given tilt of the plane reflector. The instrument is so sensitive that air currents between the optical path and the target mirror can cause fluctuations in the readings obtained. So always we are keeping this autocollimator in a closed container in an air conditioned cabin. This effect is more severe when distance between the two lenses are increased. That's why it is housed in a sheet metal or PVC plastic casing to ensure that air currents do not hamper the measuring accuracy. The major points here we have to observe is the focal length, which determines the sensitivity and the angular measuring range of the instrument. The longer the focal length gives a greater measuring sensitivity and measuring accuracy. Objective size, that is the lens size. When large apparatus is used, light conditions are more favorable and the evaluation of results is easier and more accurate. The beam splitter which are using gives the corner cubes. A physical beam splitter is recommended in most cases due to the larger measuring range. Applications, when we talk about the applications, it is used to measure the parallelism or perpendicularity of two surfaces. It is used to measure straightness and flatness. It is used to measure roll angle and also pitch and jaw measurements of slides, to assess the squareness and parallelism of components, testing of accuracy of rotary tables and index tables, monitoring of angular movements over prolonged periods of time, for machine tool adjustment, etc. So this is one of the best tools used for these applications. It is a non-contact optical type angular measuring tool. Thank you for watching this video.